you filthy swines, get in here. Sit down. I'm going to read some news. All this talk about seeding the skies with reflective particles and reducing CO2 in the atmosphere and on all sorts. Is it such a surprise that we might actually be considering the possibility we're all heading towards not a burning up of the planet, but indeed an ice age? Well, this article on Ocean Learning Hub, written by, sometimes these very fancy articles, they're just spat out from some brainiac collective. No, there doesn't appear to be anybody credited for it. Anyway, let's read this ruddy article. It says here, each year's snowfall is stacked up and preserved atop glaciers, forming layers, almost like annual tree rings, as seen here in the receding Quelquea ice cap in the Peruvian Andes Mountains. The ice traps isotopes, gas bubbles, and particles that scientists analyze for evidence of the Earth's environment long into the past. When most of us think about ice ages, we imagine a slow transition into a colder climate on long timescales. Indeed, studies of the past million years indicate a repeated cycle of Earth's climate going from warm periods into glacial, as we are experiencing now, to glacial conditions. The period of these shifts are related to changes in the tilt of the Earth's rotational axis, 41,000 years. Changes in the orientation of Earth's elliptical orbit around the Sun, called the precession of the equinoxes, 23,000 years, and changes in the shape, more round or less round, of the elliptical orbit, 100,000 years. How could you retain a record of the path of our orbit? I mean, I suppose you could take our current orbit and project it into the future, and then based upon that, you could infer what happened in the past. But you can't know for certain what happened in the past with the orbit, surely? The shape of the orbit. The theory that orbital shifts caused the waxing and waning of the ice ages was first pointed out by James Kroll in the 19th century and developed more fully by Milutin Milanovic in 1938. Ice Age conditions generally occur when all of the above conspire to create a minimum of summer sunlight on the Arctic regions of the Earth. Although the Ice Age cycle is global in nature and occurs in phase in both hemispheres, it profoundly affects distribution of ice over lands and ocean, atmospheric temperatures and circulation, and ocean temperatures and circulation at the surface and at great depth. Oh, a whole bunch of ands. All of these things conspire to make us cold. Since the end of the present interglacial and the slow march to the next ice age may be several millennia away, why should we care? In fact, wouldn't the buildup of carbon dioxide and other greenhouse gases possibly ameliorate future changes? Indeed, some groups advocate the benefit of global warming, including the Greening Earth Society and the Subtropical Russian Movement. What's that? Some in the latter group even advocate active intervention to accelerate the process, seeing this as an opportunity to turn much of cold, austere northern Russia into a subtropical paradise. I know from what I've read, the carbon dioxide levels currently in the atmosphere are some of the lowest that there has ever been. So the carbon dioxide in the atmosphere in the past has been much higher, and in those periods, they have often been much warmer. So just because there's carbon dioxide in the atmosphere doesn't mean it's going to be the end of all life. In fact, it will probably thrive. Evidence has mounted that global warming began in the last century and that humans may be in part responsible. Both the Intergovernmental Panel on Climate Change and the US National Academy of Sciences concur. Computer models are being used to predict climate change under different scenarios of greenhouse forcing, and the Kyoto Protocol advocates active measures to reduce CO2 emissions, which contribute to warming. Yes, now you get all of the well-meaning people who are not so critical, who have good hearts, being hijacked to platform and amplify the fear of global warming, which is only going to increase the desperation to reduce CO2 emissions. Anyway. Thinking is centered around slow changes to our climate and how they will affect humans and the habitability of our planet. Yet this thinking is flawed. It ignores the well-established fact that Earth's climate has changed rapidly in the past and could change rapidly in the future. The issue centers around the paradox that global warming could instigate a new little ice age in the northern hemisphere. This is the wonderful paradox of global warming will cause an ice age. Okay, that makes sense. Yes, so we need to fight global warming even harder so there won't be an ice age? Is that the point? I don't know. Evidence for abrupt climate change is readily apparent in ice cores taken from Greenland and Antarctica. One sees clear indications of long-term changes discussed above, with CO2 and proxy temperature changes associated with the last ice age and its transition into our present interglacial period of warmth. But in addition, there is a strong chaotic variation of properties with a quasi period of around 1,500 years. We say chaotic because these millennial shifts look like anything but regular oscillations. Rather, they look like rapid, decades long transitions between cold and warm climates, followed by long interludes in one of the two states. The best known example of these events is the Younger Dryas cooling of about 12,000 years ago, named for Arctic wildflower remains identified in northern European sediments. This event began and ended within a decade, and for its 1,000-year duration, the North Atlantic region was about 5 degrees Celsius colder. The lack of periodicity and the present failure to isolate a stable forcing mechanism, a la Milankovitch, has prompted much scientific debate about the cause of the Younger Dryas and other millennial scale events. Indeed, the Younger Dryas occurred at a time when orbital forcing should have continued to drive climate to the present warm state. A whole volume that reviews the evidence for abrupt climate change and speculates on its mechanisms was published recently by an expert group commissioned by the National Academy of Sciences in the US. This very readable compilation contains a breadth and depth of discussions that we cannot hope to match here. Presently, there is only one viable mechanism identified in the report that may play a major role in determining the stable states of our climate and what causes transitions between them. It involves ocean dynamics. In order to balance the excess heating near the equator and cooling at the poles of the Earth, both atmosphere and ocean transport heat from low to high latitudes. Warmer surface water is cooled at high latitudes, releasing heat to the atmosphere, which is then radiated away to space. This heat engine operates to reduce equator to pole temperature differences and is a prime moderation mechanism for climate on Earth. Warmer ocean surface temperatures at low latitudes also release water vapor through an excess of evaporation over precipitation to the atmosphere. And this water vapor is transported poleward in the atmosphere along with a portion of the excess heat. At high latitudes where the atmosphere cools, this water vapor falls out as excess of precipitation and evaporation. This is part of a second important component of our climate system, the hydraulic cycle. So basically, warm water evaporates into the upper atmosphere and takes the heat away with it. As the ocean waters are cooled in their poleward journey, they become denser. If sufficiently cooled, they can sink to form cold, dense flows that spread equatorward at great depths, thus perpetuating the circulation system that transports warm surface flows toward high-latitude oceans. The cycle is completed by ocean mixing, which slowly converts the cold, deep waters to warm surface waters. Thus, surface forcing and internal mixing are two major players in this overturning circulation, called the Great Ocean Conveyor. The waters moving poleward are relatively salty due to more evaporation at lower latitudes, which increases surface salinity. At higher latitudes, surface waters become fresher as a consequence of the dominance of precipitation over evaporation at higher latitudes. Oh, I see. That makes sense. Yeah. Just as if, what are they called? Salt farms, where you have very shallow water which then evaporates and then you're left with the salty remains. And I guess I wouldn't have expected the same kind of thing to matter so much on a much larger scale, but I guess it does. Basically, it rains a lot more north and it doesn't evaporate, so it dilutes the salinity of the water in the northern areas. The freshening tendency makes the surface water more buoyant, thus opposing the cooling tendency. If the freshening is sufficiently large, the surface waters may not be dense enough to sink to great depths in the ocean, thus inhibiting the action of the ocean conveyor and upsetting one important part of the Earth's heating system. Okay, so it's saltier underneath and fresher above. Okay, so it's separating the heat based on salinity. This system of regulation does not operate the same in all oceans. The Asian continent limits the northern extent of the Indian Ocean to the tropics, and deep water does not presently form in the North Pacific, because surface waters are just too fresh. And deep water does not presently form in the North Pacific because surface waters are just too fresh. Why is the freshness of the water dictate the depth of the water. I don't understand that. That sounds funky. Our present climate promotes the cold, deep water formation around Antarctica and in the northern North Atlantic Ocean. Conveyor circulation increases the northward transport of warmer waters in the Gulf Stream at mid-latitudes by about 50% over what wind-driven transport alone would do. Our limited knowledge of ocean climate on long timescales, extracted from the analysis of sediment cores taken around the world ocean, has generally implicated the North Atlantic as the most unstable member of the conveyor. During millennial periods of cold climate, North Atlantic deep water (NADWA) formation either stopped or was seriously reduced, and this has generally followed periods of large freshwater discharge into the northern North Atlantic caused by rapid melting of glacial or multi-year ice in the Arctic basin. It is thought that these fresh waters, which have been transported into the regions of deep water formation, have interrupted the conveyor by overcoming the high latitude cooling effect with excessive freshening. The ocean conveyor need not stop entirely when the Nadwa formation is curtailed. It can continue at shallower depths in the North Atlantic and persist in the Southern Ocean where Antarctic bottom water formation continues or is even accelerated. Yet, a disruption of the northern limb of the overturning circulation will affect the heat balance of the northern hemisphere and could affect both the oceanic and atmospheric climate. Model circulations indicate the potential for cooling of 3 to 5 degrees Celsius in the ocean and atmosphere should a total disruption occur. This is a third to half the temperature change experienced during major ice ages. So we're talking about a mini ice age. These changes are twice as large as those experienced in the worst winters in the past century in the eastern US and are likely to persist for decades to centuries after a climate transition occurs. They are of a magnitude comparable to the Little Ice Age, which had profound effect on human settlements in Europe and North America during the 16th through 18th centuries. Their geographic extent is in doubt. It might be limited to regions bounding the North Atlantic Ocean. High latitude temperatures, changes in the ocean are much less capable of affecting the global atmosphere than low latitude ones, such as those produced by El Nino. Whether the pathway for propagation of climate change is atmospheric or oceanic, or whether changes in oceanic and terrestrial sequestration of carbon may globalize effects of climate change, as suspected for glacial interglacial climate changes, are open for questions. Yet we begin to approach how the paradox mentioned above can happen. Global warming can induce a colder climate for many of us. Yeah, well, for most of the people who are obsessed with global climate change, yes, it would appear that it would affect them the most. I don't think there are people in Africa who are caring too much about climate change, or people in South America maybe. I don't know. I'm not there. Consider first some observations of oceanic change over the modern industrial record going back 40 years. During this time interval, we have observed a rise in mean global temperature. Because of its large heat capacity, the ocean has registered small but significant changes in temperature. The largest temperature increases are in the near-surface waters, but warming has been measurable to depths as great as 3,000 meters in North Atlantic. Superimposed on this long-term increase are interannual and decadal changes that often obscure these trends, causing regional variability and cooling in some regions and warming in others. In addition, recent evidence shows that the high-latitude oceans have freshened while the subtropics and tropics have become saltier. These possible changes in the hydrological cycle have not been limited to the North Atlantic, but have been seen in all major oceans. Yet it is the North Atlantic where these changes can act to disrupt the overturning circulation and cause a rapid climate transition. A 3 to 4 meter high latitude buildup of fresh water over this time period has decreased water column salinities throughout the subpolar North Atlantic as deep as 2,000 meters, which is 2 kilometers. If you're into your French miles. At the same time, subtropical and northern tropical salinities have increased. The degree to which the two effects balance out in terms of fresh water is important for climate change. If the net effect is a lowering of salinity, then fresh water must have been added from other sources. River runoff, melting of multi-year Arctic ice, or glaciers. A flooding of the northern Atlantic with fresh water from these various sources has the potential to produce or even disrupt the overturning circulation. Whether or not the latter will happen is the nexus of the problem, and one that is hard to predict with confidence. At present, we do not even have a system in place for monitoring the overturning circulation. Models of the overturning circulation are very sensitive to how internal mixing is parameterized. Recall that internal mixing of heat and salt is an integral part of overturning circulation. One recent study shows that for a model with constant vertical mixing, which is commonly used in coupled ocean atmospheric climate runs, there is only one stable climate state, our present one with substantial sinking and dense water formation in the North Atlantic. Well, that's just based on the bias of the data that we have and the models that we've been running. So I don't know if that's necessarily true. There are quite probably other stable states. Moving on, with a slightly different formation, more consistent with some recent measurements of oceanic mixing rates that are small near the surface and become larger over rough bottom topography, a second stable state emerges with little or no deep water production in the northern North Atlantic. The existence of a second stable state is crucial to understanding when and if abrupt climate change occurs. When it occurs in model runs and in geological data, it is invariably linked to rapid addition of fresh water at high northern latitudes. Okay, which I seem to remember people discussing about the Younger Dryas and the melt of all the glaciers did reduce the salinity of the Atlantic. And I think there was a giant glacier-bound lake that burst and spilt into the ocean. So there we go. That's the extent of my knowledge there. And now perhaps you begin to see the scope of the problem. In addition to incorporating a terrestrial biosphere and polar ice, which both play a large role in the reflectivity of solar radiation, one has to accurately parameterize mixing that occurs on centimeter to tens of centimeter scales in the ocean. And one has to produce long, coupled global climate runs of many centuries. This is a daunting task, but is necessary before we can confidently rely on models to predict future climate change. Besides needing believable models that can accurately predict climate change, we also need data that can properly initialize them. Errors in initial data can lead to poor atmospheric predictions in several days. So one sure pathway to better weather predictions is better initial data. For the ocean, our data coverage is wholly inadequate. We can't say now what the overturning circulation looks like with any confidence and are faced with the task of predicting what it may be like in 10 years. Efforts are now underway to remedy this. Global coverage of upper ocean temperature and salinity measurements within autonomous floats is well within our capacity within the next decade, as are surface measures of wind stress and ocean circulation from satellites. The measurement of deep flows is more difficult, but the knowledge about the locations of critical avenues of dense water flows exists, and efforts are underway to measure them in some key locations with moored arrays. Our knowledge about past climate change is limited as well. There are only a handful of high-resolution ice core climate records of the past 100,000 years, and even fewer ocean records of comparable resolution. Better definition of past climate states is needed not only in and of itself, but for use by modelers to test their best climate models, in reproducing what we know happened in the past before believing model projections about the future. We're not there yet, and the progress needs to be made on both better data and improved models before we can begin to answer some critical questions about future climate change. Researchers always tell you that more research funding is needed, and we are not any different. Our main message is not just that, however, it is that global climate is moving in a direction that makes abrupt climate change more probable, and these dynamics lie beyond the capability of many of the models used in IPCC reports, and the consequences of ignoring this may be large. For those of us living around the edge of the North Atlantic Ocean, which is most of the Western world, we may be planning for climate scenarios of global warming that are opposite to what might actually occur. Yes, maybe. And particularly if you create an upswelling of concern and a crusade against CO2 and anything that may offset an ice age, you're just going to plow us even deeper into it. So that's my fear. I'm not saying that's going to happen. That's just my opinion, and it's my fear. But a lot of the fear mongering seems pretty reckless, considering we don't necessarily have that much control over a lot of these parameters. We don't control the orbital axis. We don't control the orbital position. We have little control over the salinity of the oceans. We can measure these things. We can build up very interesting stories about what might happen, and that's what these models are. They're interesting stories, and they may be very useful. But the best thing about humanity is our ability to adapt and if we're going to replace that ability to adapt with an obsession with control, which this climate fear seems to be mostly about control and the illusion that we can control the climate. Maybe we can, but I think it's a very large planet and we're quite small. So what effect can we actually have other than making models, making stories about what might happen and then planning accordingly? I mean, all those people that were around before the Younger Dryas floods, did they know what was coming? I mean, it's debatable as to how advanced, how sophisticated people were back then. A lot of people seem to think that perhaps we were a little bit more advanced than the mainstream would suggest. Yeah, so if there is an ice age brought about by this, maybe we will be seeing sea levels dropping instead of rising, temperatures going down, historically large and extremely cold snowstorms that cover 40 of the states, maybe. I don't know. It's fuel for fantasy, though. That's my fear. Don't trust me. I don't know what I'm talking about. But that was that. If you like the show, make sure you hit the like button. If you really like the show, perhaps consider subscribing. And the only thing I have left to say is Pigwig out.
Oink, oinkity, snort, snuffle, snuffle, squee, oink, oink, wee, squeal, snort, snort, oinkity, squee. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Snort, snuffle, oink, squee, squeal, wee, snort, oinkity. Oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Oink, oinkity, snort, snuffle, snuffle, squee, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Squeal, squeal. Snort, snuffle, oink, re, squeal, re, snort, oinky. Oinkity, oink, 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 snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 oink.